Okay, we have this vector field f, this vector function f, e to the x sine y, e to the x cosine y, and 3z squared plus 2. We have to figure out whether the vector field is conservative, and if it is conservative, we have to figure out what the potential function is. To see whether it's conservative, if I call this P and this guy Q and this R, the mixed partials need to be equal. Py needs to be equal to Qx. And it's true, right? Py is e to the x cosine y. Qx is e to the x cosine y. Great. Pz has to be equal to Rx. Well, Pz is 0. And Rx is 0. And then the third check is that Qz has to be equal to Ry, and they're both 0. Okay, great. So, officially what we did was found the curl of that vector field and show that it was the 0 vector. And so, it's conservative. There is a potential function out there, and now we have to go find it. And here's how that works. The potential function should be the integral of any of the three different component parts with respect to that variable. If I integrate p with respect to x, then what I get out is e to the x sine y, but we could then add on a constant. Now, that constant function could be a function of y and z, but it can't have any x's in it. Okay. But we could do it also for q with respect to y, e to the x cosine y dy. And when we integrate with respect to y, what we get out is negative e to the x sine y. Oh, no, I'm sorry. E to the x sine y. Plus possibly some function that has x's and z's in it. And then finally, if we do it for the third component with respect to z, well, that's just 3z squared plus 2. So integrating that with respect to z, what we get out is z cubed plus 2z plus potentially some function that has x's and y's in it. And all these things have to be the same. All these are equal to phi. So how could phi, on the one hand, be equal to e to the x sine y plus some function of y and z, and on the other hand be equal to that same thing plus some function of x and z? Okay. How could both of these be true at the same time? It must mean that phi is, yes, this e to the x sine y, but when it comes time for these other functions here, they can't have, this can't have a y in it, and this guy can't have an x in it. And so we'll just say plus some function, running out of letters here, some function of z. And then looking down here at the third one, we can say what that function of z is. So we have e to the x sine y, and then plus the z cubed plus 2z. And then we can just add a random constant z. Okay, and so that's your potential function that has f as its f is the gradient of it. It's e to the x sine y plus z cubed plus 2z plus a constant. So you have to make an argument based on what these functions that could be multivariable, and it won't always end up like this, but that's how this particular one works.